Yeah, so I'm going to present or introduce a case study project we did for OKEA on the Brage Field for faster and more accurate well tests. So first bit of history on our collaboration with OKEA. We have been supporting OKEA digital transformation initiatives since the beginning, since OKEA acquired the Brage Field in 2022 from Wintershall. And even before, we were working with Wintershall on creating different digitalization applications, including a custom application that's being used to this day for with more than 30 daily users communicating between offshore and onshore. So it's been a really good collaboration, and this right now in the recent years, it's been putting resources and developing capabilities on top of the Ingenuity platform. So the project team that developed this work is on the OKEA side, Rebecca and Andreas, and on our side, Shemek and Ben, and really it was really good collaboration between these four individuals to achieve what we're going to see today. A bit on the Brage Field. Brage is a mature field. It's offshore Bergen in a water depth of 137 meters. It was discovered back in the 1980, and developed with a fixed integrated production, drilling, and accommodation facility, which has been key, I think, to the continued life of this facility and this field. So the remaining oil equivalent in place is 1.8 million standard cubic feet from an original recoverable of 70 million standard cubic feet. This does not include a recent discovery. So at the time of publishing this presentation, some discoveries were being made to actually increase the remaining oil in place. So it's quite a mature field, but still going strong. But the situation we have right now is that the new wells have a high GOR, so very gassy, and low rates. Okay, so that presents limitations in measuring the production of those wells in the existing facilities. So I'll expand on that. Basically, these high gas rate wells need to be choked in order to be tested on the test separator. Of course, when we choke the well, we're actually losing production. So it's very important to minimize the well test period. But at the same time, it's very important to achieve accurate well tests, because these are going to be used to fine tune the well production models so that we can estimate very accurate well production rates under unconstrained conditions. So we have well A11 and other wells coming on have this condition. So this is the well test application concept that we developed. And again, we've seen reincarnations of this concept a few times. We have a lot of experience in dealing with this type of problem. So basically, the idea is to have digitalization help us on this. We monitor, we start the test, we detect the start of the test, and there's a logic to detect if the well test is stable before we start a measurement period. And then once that's going, we detect the condition to end, so what we call convergence of results. At that point, obviously, the field operator can be notified. The idea is that the field operator independently can stop the well test and move on to the next test. At the same time, the production technologist can pick up automatically the well test results. He can analyze that. He can actually recalculate well test results and move on to moving the final well test to the system of record, which in this case is called Mecon, after it's been accepted. There's a part of this diagram that's in progress, which is the whole interaction with Prosper, the well model, is this part of the scope that's being developed right now. But so far, we have all the detection, capture, and well test, all of that's working. So a very simple explanation of the way this is working, very idealized. Basically, once the well is aligned to the well test separator, there's a period of stability. So the well is obviously changing, the routing is changing, the flows are adapting, and there's this period of instability where we're going to try to figure, based on different indexes and different measurements, a period of stability. So once we detect that, we call it T0, the measurement period begins. And a simple way to see this, what we're plotting is the average production to the point in time N, so continuous average being calculated by this sort of theoretical formula. And the idea is that we need to detect when that average converges to a stable value. And by the way, that nothing sudden happens, so that we don't have a sudden change in the average, which would indicate that the well actually has changed production conditions. So there's a lot of mathematics involved in this. This is a very kind of simple explanation and then obviously Ben will go into further details. But the idea is after convergence is achieved, we are confident we have an average production from that well under the current conditions, and then things can move on. So now I pass it to Ben for him to get into the demo.
Yeah, so here is the well test live view. This is the current test, which is currently in an unstable condition as the water level is above the weir, but luckily I have a historic view to show. So this here is, as I said, the live view. Like a lot of the other dashboards you've been shown today, the front end is purely no custom components. It's all made as a dashboard, and the code is all running in Node-RED. So this whole thing runs within the Ingenuity application. To overview the live view, this tracks the well test as it goes. Every 5 minutes, we run a check again. We summarize the rates, create a new payload basically, which drives the dashboard. So at the top here, we have summary values. So you get the well on test, its current status. This one, as I said, it's a snapshot from February, which is just after a well has converged. And you can see how long it's been on test. On the left here, this is a sort of live snapshot of your conditions. So for the well on test, you've got your pressures, your temperatures, your chokes. And for the test separator, you've got your levels with a brief history of the levels and the rates. On the right here, you have the results for the test so far. So for oil rates and water rates, we monitor both the change in the level of the test separator from the start of the test to now and the flow out. We calculate the volume and then divide by the time to get the rates. And then the other rates here, the derived rates, are used those averages for a calculation. And this chart on the bottom shows the full test so far with a bit of a buffer in front of it, so you can see if the previous test ended and this one started, what reason there would be. And we flag the test start time and the converge time. We also have this box, which if we track multiple tests on the same routing. So for example, if a well is routed to test, it starts doing one test and then one of our interruption criteria comes up, which is the choke changing significantly, the GL choke, the water level in the test separator exceeding the limit for over 15 minutes, then that test will end. But if another one starts, we let the user quick jump between them to compare, and then you can navigate quickly to the history from there. The dashboard supports multiple sets of units for rates. You can pick between meters cubed per hour, day, and barrels per hour and day. And we also have a comparison to the last approved test values for a quick glance to see if this test looks like it's representative of what you're expecting. And we also have the ability to, as a user, subscribe to alerts. So when a test converges, you can get an email that summarizes the details, and then you could make a decision of whether you agree with our convergence criteria and the well test is good, or you'd like to leave it on a bit longer before you accept the test. So then we jump to the historic view. So this shows us all the previous tests we've done and saved. We save all tests when they finish to our internal event log system, which we again just browse with values. So here, obviously, you can filter by which well. We also include options. Sometimes there'll be a piggyback test, so it'll be multiple, but when you drill in, it will tell you which wells were tested, and we track the rates there. But more interesting are the single well tests. So we track when it was, the duration, and its state. So state is converged if we reach the period, as Joel said, where the rates basically converge down to a fairly consistent average. We basically say that's good. The test looks like you've got a good snapshot that represents a single behavior, but it might be a test ends before we reach that point due to an interruption condition. So if the well on test was switched or the choke was changed, GL choke, before we believe it reached that state, you might see converging. And there's a couple other states for manual override, manual creation, which I will mention later. But yeah, on this screen, you can see the end reason as well and the submission status, which I will get into on the next page. So this here is a finalized test, the complete, and this is where you can browse all the details. So as you can see, it gives you again which well was on test, the status, and you can see the rolling average of the test and where we said it converged, and then a full view of all the details. We exposed the obviously when it was routed. So if there were multiple tests done in one routing, you might see the routed to test and the test start being different because it's not the first one. The status again, the reason for end, the event ID, which you can copy and then use some of our other external systems to access this event and look it up with our SDKs or from the event browser directly. And then you've got the results, which is of course all the calculated values. And on the right here, some charts that help user basically view the test and agree with it. So you can see this one started here when the routing changed. We felt it converged here and went on until the well on test, which is this white line, was switched. And this chart underneath is more observation of our interruption conditions. So the chokes, the water level, the oil level, so you can have a look and see if anything there. If the choke suddenly changed, you might say, oh, that's the reason the test ended, etc. We also allow for here, you can accept and reject the test from this page, which allows you to add a comment. This basically just tags the event in our system. And with the Mekon integration that Joel mentioned, when you can choose to push an event, whether you accept or reject, there'll be an additional option to push. But if it's a rejected one, it will be flagged as an invalid test. So it won't show up on other applications that are used for seeing only good tests, but you might want to keep the test for posterity reasons so you can see what you had at the time. And then once you've submitted a test, the details here will show of the status will go to accepted or rejected. It will have the date, who added it, and any comments. The Prosper simulation side we are working on at current, as Joel said. It basically for this, it's just we push some of the values we recorded in the test to calculate a simulated DHP, which we then compare to the measured one. And that's really used for tuning the well model. And again, we have a link to other results from the same routing. This page as well can be switched to any units you want. We plan with the Prosper to run on a schedule, so at midnight, all recent tests will be processed and updated. There's also the option on this page to adjust the bounds of a test. This is if you see a test that you think the reason it was interrupted was wrong and it could have been a longer test, or vice versa, there was an anomalous result sometime in the test and you'd rather shorten it, you can edit these bounds and it will fully recalculate this test. It won't just change the bounds, it will go to IP21, query all the raw data, sample the data, and recalculate all these values and save it again. So if you aren't quite happy with a result, you can tweak it, but the well will then update the status to a manual override and it will change to the user's name who updated it up here, just so you can track any changes made. There is also a method we are working on for generating an event from scratch via a UI in case of times when instability or interruption condition was unavoidable. So the application might have, say, the water was over the weir, but you needed some result for the time. You'd be able to say, generate me a test from this period, and it would ignore the interruption conditions, but it would be classified as a separate test for clarity.
So, just for closing remarks, benefits of this, obviously, we have more accurate well tests, which are very important for this field to optimize gas lift optimization and to make decisions about the operation of the field. Obviously, everybody gets notified automatically. They can subscribe and get information about that. As you saw from the demo, there's several options actually to even create synthetic tests from the data, so nothing is lost. Once the data is being captured by the system, we can generate tests from that data. Obviously, more wells can be tested in the same time frame. The example we saw converged in 1 hour, 15 minutes, which is quite short. And then the control room can make their own decisions. And as a consequence, less time will be required by the production engineer. Basically, the production engineers have all the tools in their hands now to achieve the level of information that they need. And they will have more time to optimize the field. So that's the summary of the benefits.